Yes, good morning, all of you. Let us quickly revise our chemistry paper 2, unit 1. In that, there are three subunits: ionic equilibria, molecular spectroscopy, and solid state chemistry. Let us first quickly revise solid state chemistry. In solid state chemistry, we have seen concept of solid, liquid and gases, okay, points of differentiation. And since we are dealing with solid state chemistry, quickly remember the types of crystalline solids, solids as amorphous solid and crystalline solid. Then we have gone through different characteristics of crystalline and amorphous compounds, okay, where there is definite arrangement of crystal is called as crystalline solid. They have sharp melting point. Viscosity is low for the crystalline compounds. There is regular arrangement, and crystalline compound expands only 10%, okay, after melting, and they are called as anisotropic crystals, okay, crystalline solids. Then amorphous solids के लिए हमने देखा था they are not having definite geometrical arrangement, okay, so therefore melting points come in range, and they have very high viscosity, and they are isotropic, okay. Meaning of anisotropic and isotropic also we have seen. Amorphous solids, they are also called as supercooled liquids, okay. They are supercooled liquids. Amorphous compounds को supercooled liquids भी बोलते हैं. Then we have seen different laws of crystallography. Before that, just we have seen different features of the crystals. What are phases? Okay, so remember each and every definition of the um, phase, form, age, interfacial angle क्या होता है, what is zone and what is zone axis. Okay, so remember all the definitions of this. Then we have seen laws of crystallography. There are three laws of crystallography: law of constancy of interfacial angle, then law of rational indices, law of symmetry we have seen, okay. Simply law of constancy of interfacial angle ये क्या बताता है? दो shape and size of certain compounds or element may vary with the conditions under which they are prepared, but the angles between faces are always constant, okay. So this is law of interfacial angle. You can see one compound is there which is having different shape and size, but the interfacial angle between adjacent faces is constant in all the three possible shapes of the molecule, okay. So this angle is measured by instrument called as goniometer. Then in law of rational indices, we have seen about the growth of crystal. Okay, it always takes place in a ratio of HA as to KB as to LC, and where we have followed the calculation of Miller indices. Miller indices are what? They are obtained by taking reciprocal of base indices and multiplying by LCM to obtain integral values. Okay, so go through examples of calculation of Miller indices for given species. Okay, so LCM calculate करते time for fractions you take formula, okay. तो डिनोमिनेटर में जो रहेगा उसका LCM निकालना है आपको. Then third law is related to law of symmetry. Okay, this law states that crystal of same substance possesses same numbers of symmetry element. And in this unit we will see focus on only three symmetry elements: plane of symmetry, axis of symmetry, and center of symmetry. Okay, plane of symmetry is always two-dimensional surface. Axis of symmetry is one-dimensional, it is line. Okay, center of symmetry is just one point. Okay, it is zero dimensional. So plane of symmetry हमने देखा था. There are different planes, rectangular planes. एक cubic system लिया तो there are three rectangular planes. Okay, you can just check these three are the rectangular planes of the molecule. Okay, so plane क्या है? It is imaginary plane by which if crystal is divided into two parts. Okay, if we just divide this whole cubic crystal into two parts, so one part, okay, this left hand side will become exact mirror image of other half. Okay, so this uh, rectangular plane in this case will be the plane which will separate two given molecule into two equal halves. So one half will reflect as mirror image of other half. So three rectangular planes are there. Diagonal planes के लिए देखा था हमने, diagonally अगर connect किया तो you will see कि this brown kind of two diagonal planes will be there if you connect this point with this point, again again this point with this point. So two diagonal planes of this kind you will obtain, and another diagonal plane can be, you can just connect upper side के two planes with the uh, 2 points with the opposite के bottom के. Okay, so since this way you can produce four. Okay, four sides are there, so you can prepare four such a type of diagonal planes. So total 6 plus 3, 9 will be the planes present in the molecule. Okay, axis of symmetry के लिए हमने देखा था कि it is imaginary one dimensional line. Okay, line is always one dimensional through the crystal, about which if crystal is rotated through angle 360, okay, so round rotation, it gives same appearance, so that will be n-fold axis. Okay, four-fold में 90 degree is the uh, angle of rotation. Okay, after every 90 degree you will find कि you are getting similar kind of appearance. Three-fold में it will be 120 angle, so after 120 rotation you will get. So this you can see, this is the imaginary line, dotted line in the molecule, by which when you rotate, okay, you will get similar kind of appearance. So depending on that, there are four-fold, three-fold, and two-fold axis of symmetry. Four-fold axis of symmetry molecule में कितने रहते हैं? There are three. Three-fold axis of symmetry in the molecule are four. For cubic geometry we are talking, and for two-fold geometry it is six. Okay. Then center of symmetry is one point. Okay, from which along plus x minus x direction you will get same distance, another point will be located at same distance. Okay, so for cubic this will be the center of symmetry, you can touch any face at equal distance in the opposite direction. Okay, so plus x or minus x opposite faces अगर distance calculate किया, it will be the same distance. Okay, plus y minus y अगर calculate किया, it will be the same distance. Okay, now remember the copper sulfate pentahydrate molecule, CuSO4 5H2O molecule. This molecule is not having any symmetry element. So the detailed discussion we have seen how this molecule is not having any center of molecule. Now for NaCl you will find it is face centered cubic system. Okay, totally it is having 23 symmetry elements. Okay, NaCl is having total 23 symmetry elements. Then apart from this, laws of crystallography prepare for all the definitions under space lattice unit cell. क्या होता है? Okay, unit cell is what? It is smallest repeating unit of the crystal. Okay, it is building block that repeats, okay, is unit cell. Crystal lattice क्या है? Geometrical pattern of points. Okay, so just we have seen the orderly three-dimensional arrangement. Okay, highly ordered three-dimensional arrangement of atoms in the space is the space lattice or crystal lattice, whereas unit cell is what? It is smallest unit of crystal lattice is the repeating unit. Okay, देन लैटाइस प्लेन के लिए हमने देखा था जस्ट प्रिपेयर फॉर डिफरेंट प्लेन्स. देन ब्रेवियस लैटाइसेस हमने देखे थे ऑल सिस्टम्स. ओके, देयर आर टोटल 7 क्रिस्टल सिस्टम्स हैविंग टोटल 14 brevious lattices. Okay, so for each now crystal system, remember the uh, lattice parameters क्या है? Length and angle. Lengths are, side lengths are a b c, length along x y z axis. Okay, angle alpha beta gamma. Alpha angle क्या है? Which is opposite to line a, angle between c and b. Okay, beta क्या है? Angle between C and A opposite to B. Okay, angle gamma is the angle between A and B. Okay, so that is angle and length. For Harek system, you just remember tabular form is given here. Okay, so prepare carefully the lattice parameters for given crystal system. Okay, so any of given crystal system will be given to you. So remember the lattice parameter. In regular lecture, I have told you how to remember these lattice parameter. Okay, so go on disturbing one side. First change bond one of bond length. Okay, cubic z axis along elongate किया तो you will get tetrahedral structure. Okay, तीनों भी axis direction में elongate किया. Okay, some elongation along x, some elongation along yz, so that you will get all three sides different, but box will be 90-degree only. Angle will be 90-degree only, so that will be orthorhombic. Okay, so that way you can remember this. So I hope you will prepare for solid state chemistry topic very carefully. Okay, and uh, then we will quickly now revise unit number subunit number 1, which is ionic equilibria. Okay, in ionic equilibria we have seen different characteristics of the uh, electrolytes. Basically, what is electrolyte? It is the species or substance which forms conducting solution on dissolution in water. Okay, so how it dissolves in water and how it forms ions. Okay, so that is electrolyte. So all the bases, acids, salts are the electrolytes, and based on that we have seen the strong and weak acids and bases concept. So remember the examples under strong, remember examples under weak. Then degree of dissociation we have seen, it is number of moles of electrolyte undergoing dissociation divided by total number of moles present in the solution. Okay, that is degree of dissociation, and from that dissociation constant values also we have seen. Okay, so for strong electrolyte, degree of dissociation is almost 1. But for weak electrolyte is electrolyte which dissociates to very less extent. Okay, so degree of dissociation alpha value will be very low, less than 1 for weak electrolytes. Okay, so remember points of differentiation between strong electrolyte and weak electrolyte over here. Then we have seen different factors affecting degree of dissociation. Okay, so remember each factor and its effect. Concentration, how with respect to concentration of solution degree of dissociation increases or decreases. Then temperature we have seen, usually with respect to temperature dissociation increases. Then nature of electrolyte, sorry, then nature of solvent, common ion. Okay, so these effects we have seen. So like for effect of concentration, remember the strong electrolyte H2SO4 in the very concentrated form is weak electrolyte. Okay, H2SO4 we call it as strong electrolyte, but remember any concentrated H acid or base will be weak electrolyte because the space for dissociation will be reduced. Okay, and dilute electrolytes are the strong electrolytes. Remember this one. Okay, effect of concentration. Then temperature, usually with temperature it increases. Nature of electrolyte, whether it is strong or weak. Strong electrolyte will dissociate completely, weak electrolyte will dissociate to less extent. Okay, then we'll see about the common ion effect. Okay, common ion effect is what degree of dissociation of weak electrolyte is suppressed, okay, or decrease by addition of strong electrolyte which contains common ion. Okay, so we have seen example under base category, under acid category, like for acetic acid, degree of dissociation of acetic acid is suppressed by addition of sodium acetate, whereas for ammonium hydroxide, degree of dissociation of ammonium hydroxide is suppressed by addition of ammonium chloride. Okay, ammonium chloride and sodium acetate are the strong electrolyte which contains common ion. Okay, so acetate ion is common with acetic acid and NH4 plus ion is common with ammonium hydroxide. Okay, then we have seen Ostwald's dilution law. Basically this is applicable to weak electrolytes. Okay, what it says ki at given temperature, degree of dissociation of weak electrolyte, that is alpha value, okay, is inversely proportional to square root of concentration of solution and or directly proportional to the square root of volume. Okay, so alpha, which is degree of dissociation, is either inverse, you can say inversely proportional to square root of concentration or directly proportional to square root of volume. Okay, so this is for weak electrolyte, remember. So therefore for weak electrolyte you can calculate concentration as alpha into C. Okay, concentration of species can be calculated by using alpha into C. So if you know this equation, you can simply calculate some concentrations. Okay, so just go through some of examples also. Like the degree of dissociation of acetic acid in zero point 0.1 molar solution is given to you. Okay, in one concentration it is given, so this will be your alpha 1. Okay, in the concentration 1 C1, and what is us degree of dissociation alpha 2 in C2, अलग concentration में कितना है, so alpha 1 C1 are given, alpha 2 calculate करना है, C2 is given, so just by cross calculation you will get. So use simple equation, dissociation constant is equals to your equation earlier was alpha is equal to square root of k upon c. Okay, so just simplify that equation, k will be equal to alpha square into c. Okay, so take proportion for both and just cross calculate it. Okay, so simple calculations are also expected over there. Then for strong acids and bases, strength of acids and bases we have seen with respect to dissociation constant. Then ionization of water and pH of consent will come. You know, ionization of water, when 2 moles of water are taken, it forms H3O plus ion and OH minus ion, and the equilibrium constant for this reaction is called as ionic product of water, and it is always having value 10 raised to minus 14. Okay, so remember this, H plus and OH minus is always equals to 1 into 10 raised to minus 14. Okay, kW of water, ionic product of water is 1 into 10 raised to minus 14. From that pH scale is derived. So if that ionic product may both are having same concentration, H plus and OH minus, solution can be neutral. Okay, if it is having more concentration of H plus ion, solution will be acidic. Or if it is having more concentration of OH minus ion, it will be basic solution. Okay, so we have then derived the pH scale. Remember the definition of pH, it is logarithm to the base 10 of reciprocal of hydrogen ion concentration, or you can simplify it negative log to the base 10 of uh, concentration of hydrogen ion present in the solution. Okay, so this formula you can apply, or this formula you can apply. So remember, pH scale starts with 0 to 14. Below 7 it is acidic, at 7 it is neutral, above 7 it is basic. Okay. Then remember the pH values of some important things like gastric juice, jo everything we eat it digest. Okay, so 2.0. Then soft drinks around 3, rainwater around 6, मिल्क का pH होता है 6.5, प्योर वाटर is 7, human blood is having pH 7.3, and we have seen consequences also. Sea water का pH रहता है 8.5. So remember pH and pOH values, or pH values of all these. Then what is correlation between pH and pOH? Basically pH is what? Potence of hydrogen ions, and pOH is potence of OH minus ions. So for basic solutions, you will calculate POH and pH plus POH will be pK. W will be equals to 14. Okay, so just take negative log to the base 10 of 10 raised to minus 14 raised to power का ये आगे आ जाएगा minus 14 minus minus will become plus. Okay, तो log of 10 is 1, so answer will be 14. Okay, so pH plus POH is equals to pKW. From that we have seen very simple calculations of pH. कोई भी सॉल्यूशन का pH निकालना रहेगा तो 10 रेस टू पावर में उसको कन्वर्ट करना है. ओके, 0.01 दिया रहेगा तो जस्ट कन्वर्ट इनटू 10 रेस टू पावर 1 इंटू 10 रेस टू -2, ये -2 आगे आ जाएगा. सो सिंपली 2 विल बी द pH value. Okay, so simple equations also we have seen, but take precaution when you will calculate for basic solution. Okay, that will be your POH. जो आंसर आ जाएगा वो POH आएगा एंड देन 14 माइनस PH. POH करने के बाद आपको pH का वैल्यू मिलेगा. तो just to tally your answer, remember acids are always having pH value below 7. Bases are always having their pH value above 7. Okay, so that will be cross check of your answer. Then just go through some of simple examples. Common ion effect हमने देखा था. Okay, factors affecting देखा, dissociation of acids देखा, diprotic triprotic का भी. Then we have seen कि pH of very diluted solution, pH value of very diluted solution can be calculated by just taking. There then buffer concept of buffer solution is also there. Just we will see that.